to downward. Okay, let's go and solve another problem. An 18 Newton weight is supported by a cable attached to a 2-meter strut hinged at a point A as shown in the figure below here. So what's that again? An 18 Newton weight, this is the 18 Newton weight, suspended by a cable attached to a 2-meter strut. This is the 2-meter strut, and it is hinged to a support there. The strut is supported by a second cable. The strut is supported by a second cable under a tension T. The mass of the strut is 5 kilograms. So the mass of this beam, if you want to call it, is 5 kilograms. Now what are we supposed to find? What are the 4 forces acting on the strut? Well, I specifically said there are 4 forces. What are the 4 forces acting on the strut? Find all the 4 unknown forces. Can you talk about the forces acting on the strut? What are these forces? Well, there are a couple of forces very obvious. One force is the weight of this object, that is 18 Newton acting vertically down as one force. This is the tension force acting at an angle 30 degrees. Second force. What is a third force? A third force is the weight of the strut. Where is the point through which it is acting? At its center. So the weight of the strut will be acting vertically down. What is the fourth force? There is some kind of force at the hinges. We don't know in what direction the force is. And therefore, now look at the way we are going to approach it. We don't know the direction of the force at the hinges. So we are going to say, let it be in any arbitrary direction. Let the force at the hinges be somewhere in that direction. In any direction. Now, in such a case, it has a horizontal component and a vertical component. So mark those components. Let its horizontal component be called H and the vertical component be called Y. So we are now going to say whatever force exists at this hinge is now broken into a horizontal component H and a vertical component V. Once you are able to find H and V, we know how to find that F. Is that right? I'm sure you know it. Alright, what's the method we are going to use? Okay, let's now solve this problem. The strut AB is in equilibrium under the action of these several forces we just talked about. So the first thing to do is, let's isolate the strut and draw a separate diagram. This is the strut. And let's draw the diagram of draw the various forces. What are the forces? This is the point A, that's the point B, and C is the center of the strut. That's your C. The weight of the strut is its mass times G, 5 kilogram times 9.8 meter per second squared, is 49 Newton, will be acting vertically down. The weight 18 Newton, remember this is given in newtons, not in kilogram, so you don't need to do anything with it. This 18 Newton will be acting vertically down from the point B. Now, the tension T on the supporting cable, this is the tension T, and the angle it makes with the strut is 30 degrees. Remember, it is not the angle it makes with the positive x-axis. It is the angle it makes with the strut. Alright. Now the hinge at A exerts a force on the strut. Since we are not sure of the direction of such a force, we assume that this force is made up of a horizontal component H and a vertical component V. Now that's a very neat way to approach when you don't know a force. So let the force at the hinge be represented by its horizontal component H and the vertical component V. We now resolve this tension force into the horizontal and vertical component. Now tell me, can you use this 30 degrees and tell me what is the horizontal component of that T? The horizontal component is T cos 30 degrees. So this is the horizontal component, that is T cos 30 degrees. And what is the vertical component? The vertical component is T sine 30 degrees. There you are. And now you have all the forces in the proper directions. Look at this. V is the positive y direction. T sine 30 is in the positive y direction. 49 Newton negative y direction. 80 Newton in the negative y direction. We have also some x forces. What are they? The force H is in the positive x direction. The force T cos 30 degrees in the negative x direction. Alright. H and T cos 30 degrees are x forces. H is a positive x force. T cos 30 degrees is a negative x force. So, if I now use this condition, summation fx equal to 0, what does it mean? It means add all the x forces and set it equal to 0. It means positive h minus t cos 30, isn't it? This is negative. So h minus t cos 30 degrees equal to 0. We produced one equation. And write it like this. H minus 0.86t equal to 0. You got one equation having unknowns h and t. And now let's look at the y forces. Summation Fy equal to 0. What are the y forces? V is a positive y force. T sine 30 degrees is a positive y force. 49 a negative y force. 80 Newton a negative y force. So it will be V plus T sine 30 degrees minus 49 minus 80 equal to 0. There we have summation Fy equal to 0 gives me this. And let's simplify this. This will be, can you tell me, sine 30 degrees is 0.5. So it will be V plus 0.5t, and take the negative 49 and negative 80 to the other side. We get this equation. V plus 0.5t equal to 129. You can see we have two equations, but can we solve these two equations? We got three unknowns. So we still cannot solve these equations. We need to get one more equation. Now tell me, where is that equation going to come from? It's going to come from summation tau equal to 0. In other words, we take the torques of all these forces about any convenient axis. Tell me, give me a point which is the most convenient. I want you to watch here. Watch this point A. The force H passes through A. The force V passes through A. And watch this. The force T cos 30 degrees also passes through A. That means, if you take the torques of all the forces about the point A, the torque of H will be 0. The torque of V about A will be 0. The torque of T cos 30 degrees about A will be 0. Look at that. We have 3 forces passing through A, and because the torque produced by each of these forces about an axis through A is 0, we will eliminate that from our equation. You see, that is a neat strategy. Alright, we now take torques of all the forces about the point A. You know why I chose point A. Alright, let's write down that. The torque of the force V about A is 0 for obvious reason. The torque of H about A also is 0 because H also passes through A. And the torque of T cos 30 degrees about A is 0 because that force also passes through A. The torque arm is 0. Well, the distance from A to B is 2 meters, the length of the strut. The torque of T sine 30 degrees about A. Look at that. T sine 30 degrees is this force. What is the torque of this force about an axis passing through A? The torque arm is this distance, the perpendicular distance. That would be 2 meters multiplied by T sine 30 degrees. And look at the way I simplified it. Sine 30 degrees is 0.5. 0.5 multiplied by 2 is 1. 1 multiplied by T is T. So that torque is T meter Newton. Now this is a counterclockwise torque. Look at that. The torque of this force about A is a counterclockwise torque. Therefore, it is positive. Okay. What is the torque of 80 Newton? What is the torque of this force, 80 Newton about A? The torque of 80 Newton about A is the torque arm is 2 meters multiplied by the force is 80 Newton. It will be 2 multiplied by 80, but that torque is a clockwise torque. Therefore, it is 2 meters times 80, and that is negative 160 meter Newton. A clockwise torque is negative. Alright, what is the torque of the 49 Newton? You can see 49 Newton is at the point C, and the distance of that C from the point A is half of this 2 meters, 1 meter. What is the torque of 49 Newton about A? It will be the torque arm is 1 meter multiplied by 49 Newton. That will be negative 49 Newton. Why negative? Again, the torque of the 49 Newton about the point A is negative. It's a clockwise torque. Alright, let's now add all these torques. Summation of all these torques will be 0. Look at that. T minus 160 minus 49 equal to 0. That is what you get by applying summation tau equal to 0 is T minus 160 minus 49 equal to 0, and that gives you the value of T right away. We've got the value of T, and once you have the value of T, you can take it to equation 1 and you can get the value of H. So using this value of T in H minus 0.866 T equal to 0 gives you H equal to 181 Newton. I just used the value of T there. So we solved for T, we solved for H. We now need to solve for V. That means take the value of T to your